If you're on the coordinate plane, you can find the distance as well as the midpoint of a segment or between those 2 points. We're going to work with the distance first. So if we're given 2 coordinates, then our distance between those points is the square root of x1 minus x2 squared plus y1 minus y2 squared, and that's all underneath the square root. Now, realistically, it does not matter whether you pick x1 to go first or x2. It's x minus x. And the reason why it doesn't matter is because if you were to subtract those two numbers, even if it were negative, you're squaring it. So because of the fact that you're squaring it, you're not taking into account whether or not it's actually negative or positive. That's why it actually does not matter which point you choose as x1 and x2. So, for example, let's say I have the coordinates 4, 6 and -1, 3. All right, so all I'm going to do is I'm just going to plug this right into my distance formula. The biggest thing is that people have troubles with is simplifying the radical. So we've got 4 minus -1 squared plus 6 minus 3 squared. All right, so realistically, that's 5 squared plus 3 squared, still underneath the square root. So we've got 25 plus 9, still underneath the square root, which gives us the square root of 34. Now, this is the part that most students have troubles with. If you were to have a perfect square that would go into 34, you would break this down. In this case, we don't. So our distance between our 2 points is the square root of 34. Leave it in radical form. Do not simplify or do not give me an estimation. So like I was saying with the simplification of radicals, we might just want to go through a brief one here as a refresher. So let's say I have the square root of 72. Okay, so what I'm going to do is I'm going to be looking for a perfect square that goes into 72. So what that means is I'm looking for a perfect square that when divided by, so I take 72 divided by that perfect square, it actually comes out to an integer. So I'm going to break this down, in this case, into the square root of 36 and the square root of 2. So you have those little cheat sheets that's got the x squared, and the x cubed columns. You are going to be working on the middle. So you're trying to find a middle number that goes into 72. When you break it down here and you split it, they're still both underneath the square root. The square root of 36, though, is 6. So our final answer is 6 square root 2. And that would be because square root 2 cannot simplify any further. All right, so just a little recap there of how to simplify radicals. Distance formula, like I showed you already. The midpoint formula. Midpoint formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. Now, with this, this is set up as a coordinate. Leave it as a fraction. I don't need decimals. You can leave it as an improper fraction. I'd prefer that you leave it that way. So, for instance, if I wanted to find the midpoint between the points, we'll go with the same ones, 4, 6 and -1, 3. So, for the midpoint, I've got 4 plus -1 divided by 2. And then 6 plus 3 divided by 2. which would then leave me with 3 over 2, comma, 9 over 2. Final answer. Again, leave it as improper fractions. I don't want to see any decimals. Granted, I know it's just over 2, but the point being, just leave it as improper. So that's our midpoint formula. This is our distance formula. And here we just simplified the radical just as a refresher.